Hello students. In this video we are going to discuss about a very important part in the organic chemistry, that is the nomenclature of organic compounds. The organic chemistry deals with millions of compounds. In order to clearly identify them, a systematic method of naming has been developed and it is known as IUPAC naming. That means International Union of Pure and Applied Chemistry, the system of nomenclature. So in this video, we are going to discuss some important terms we'll be using for writing any IUPAC name for any organic compound. So first, let us talk about some important terms for writing the IUPAC name of organic compounds. That is word root, substitutes, functional groups. So let us find out what is these word root, substitutes and functional groups in detail. First of all, word root. It represents the number of carbon atoms present in the main chain. What is word root? It is representing the number of carbon atoms present in the main chain. That for writing the word root, first we have to learn the names which we have to use as a word root, which is representing the number of carbon atom present in the main chain. Like if there is one carbon atom in the main chain, then we have to use the word root meth. If it is 2, eth, for 3, prop, for 4, but, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, 10, dec. So these names you have to learn in order for writing a IUPAC name for any organic compound. So what the word root is actually, it is representing the number of carbon atoms present in the main chain. So let us take one example here. This is one organic compound. Let us count the number of carbon atom present in this main chain, because here there is only one chain, so that is the main chain. So here how many number of carbon atoms are there? Just count it here. 1, 2, 3, 4, 5. Here there are 5 number of carbon atoms. So what will be the word root for this organic compound? 5 number of carbon atom means the word root will be pent. So pent will be the word root for this one. And what will be the name for this one? You are familiar with this compound, that is pentane. So in detail we'll be discussing later on about the what we are suffix we are using here. So just remember here what the word root says. It represents the number of carbon atom present in the main chain. Let us take another example. A cyclic compound. Let us count the number of carbon atom present in this. So I told you it's a bond line structure. So each corners and tips represent the carbon here. So let us count the carbon number here. Here is 1, here is 2, 3, 4, 5, 6. Total 6 carbon atoms are there in the main chain. So what will be the word root? Because 6 it is there, so word root will be hex. So it is actually, the name of this compound is a cyclohexane. So here hex word we are using, that is a word root. So what is a word root? It represents the number of carbon atom present in the main chain. Let us take one more example. This example. Let us count the number of carbon atom here. 1, 2, 3, 4 carbon. So here the word root will be but. And what will be the complete name? That will be discussed later on after learning all the terms. So it is clear that what is word root? It represents the number of carbon atom present in the main chain. And in order to write the word root, it is necessary to learn this. That is the root name, that is meth, eth, prop, but, pent, hex, hept, oct, non, dec. So it's very important to learn from 1 to 10 the root name, so that we can write the IUPAC name for the different organic compound. Let us talk about next substitutes. Substitutes are the groups which are not regarded as a functional groups. So here these substitutes are actually a group. That means it's not a complete molecule. It is a part of a molecule which is called as a substitutes. Here the most important substitute, that is the alkyl group. As I told you, substitutes are not the complete molecule. These are the group, means the part of the organic compound here. So if the part is actually, let's talk about an alkyl group. Alkyl group is generally represented in capital R, that is alkyl group. Alkyl group we represent by capital R. And here the line shows like this R, and one line it is written. This dash shows that it is a group because it is connected to some part of any organic compound. So it is not a complete molecule, it is a group. We can say a part of the organic compound. So that's why this dash shows that it is connected to any one of the chain of the carbon or any ring of the carbon chains. So here let us talk about more about the alkyl group. Alkyl group, how we find out, how we name the alkyl group by this table, because alkane and alkyl. Now what is the relation between alkane and alkyne? As you have learned already the formula for alkanes like methane, ethane, propane, butane and so on. So here alkane having the formula, let's take taking the case of methane. Methane, the formula is CH4, that is methane. Methane is an alkane, that means it is a molecule, it is an organic compound. But if I'm saying a group, if I'm saying the group, then I have to remove one that is one hydrogen we have to remove from here. So that will now it become 3, this dash. So this dash shows that it is a group. Now it is not called as a compound. Now it is called as a group, which is called as methyl group. And the general word we are using, that is alkyl group. As you are already familiar with the general formula for alkanes, that is CnH2n plus 2. That is the general formula for alkanes. Now what will be the general formula for alkyl group? How we write the general formula for alkyl group? Just remove one hydrogen from this. So here 2n plus 2 is here. So this we can write here the general formula for this is, that is CnH2n plus 1. Now because what is the relation between alkane and alkyl? Because alkanes having whatever number of hydrogen is there, from that one hydrogen when you remove it and you'll keep a dash here, that shows that is an alkyl group. So as I told you, in the case of alkanes, the general formula is CnH2n plus 2, but for the alkyl group the general formula is CnH2n plus 1. And it is very important here to write the dash, because dash shows that it is a group and it is connected to an organic compound. So here the alkyl group like methyl group. Now how the word comes methyl here? Methane, CH4. Now you remove one hydrogen from here. So what we get? CH3, and it is very necessary to keep the line that shows a group here, that is called as methyl. Similarly, when you take ethane, C2H6, remove one hydrogen. So what you get? C2H5, that is what it is written here, CH2CH3. CH2CH3, how we can write here? CH2CH3. This we can write like this also. Total number of carbon 2. So C2, and here 2 hydrogen, 3 hydrogen, so 5. So instead of writing CH2CH3, we can also write C2H5. So that is what the group that is called as ethyl group. So similarly, for propane the formula is C3H8. So what will be the formula for propyl group? That is C3H7. That will be C3H7. Look at here. Propane formula is C3H8 and propyl formula is C3H7, and don't forget to keep a dash. And in order to come valency get 4, you can check the valency gets satisfied with this dash. So it is very important to note the alkyl group. Even there are some complicated alkyl groups also, like this. The branched alkyl groups are like if 3 carbon with it is in the branched form, then it is called as isopropyl. Next we have secondary butyl. 1, 2, 3, 4 carbons are there. Therefore but word we are using, and it is a substitute. It is an alkyl group, therefore we use the word butyl. And why it is called as a secondary carbon? That because here the attachment on this carbon, that will be discussing later on in detail. Next, this is called as isobutyl. Again 1, 2, 3, 4 carbons are there, therefore butyl word we are using. Whenever this part is there, that is called as iso, that is CH3 CH CH3. Whenever this part is there, that is called as iso. So it is called as isobutyl because there are total 4 number of carbon. So when you check it here, there are 4 number of carbon. So what is the formula for butane? That is C4H10 is butane. So what will be butyl? That is C4H9. Now you counted number of carbon and hydrogen in this, you will be getting C4H9. But the normal butyl will write in the straight chain, but isobutyl, that is in the branched form. So these the names are given, that is called as normal alkyl groups or N-alkyl groups, in which the carbon atom are in a one chain. But here it is branched chain and it will be named in this way. So similarly we have tertiary butyl here, neopentyl. That is all are the different substitutes or the different alkyl groups. Even the substitutes can also be alkoxy group. Now what is alkoxy? R, as I told you, represent the alkyl group and O is representing the oxygen, that is together the name word comes here, that is alkoxy. Alkoxy, that is alkyl group and with one oxygen, that is called as alkoxy. It is very important to learn all these terms. Let us take one example. One alkyl group I am taking, that is CH3. CH3 is the alkyl group with one oxygen, and I told you there should be a dash for the substitute because it shows that it is a part of a organic compound. It's not a complete organic compound, it's a part of an organic compound. That's why it is called as a group. So CH3O. What is CH3? As we have learned, CH3 is a methyl group. So methyl group and one oxygen, that is called as methoxy. So what we give the name for CH3O, that is methoxy. If I take the next case, next example, C2H5O. What we give the name for this one? What is C2H5? C2H5, that is 2 carbon, means eth. And one oxygen is there, that is ethyl group and oxygen, that is the name comes as ethoxy. The name we can use, that is ethoxy. The next one, the next substitutes, that is actually the halo group. Halo group means actually the halogen groups are called as halo groups. If the organic compound have fluorine as that is a halo group, if it is there attached to the organic compound, then it is called as fluoro. Here the name word we are using here as fluoro. We'll be giving the name for this as fluoro. In general, we are using the word here, the name as hello, but particularly if F is there, we'll use the name as fluoro. If Cl is attached to the organic group, organic compound, then it is called as chloro. So what about Br? If Br is present, then it is called as bromo. Similarly, if I we have in the organic compound, then it is called as iodo. So these are the substitutes, and these are generally called as halo, and we write X for representing in general the halo group we can represent by X. So it is also very most important part in this. The next one we have some substitutes like NH2, so that is called as a amino group. So in details of these will be getting when we do some practical examples. The next part is the functional group. That is very most important part. The group that determines the characteristic properties of an organic compound is called as functional group. That means a group which is actually determining whether this organic compound is an acid, or it is a amine, or it is an alcohol, or it is a ketone, or it is a aldehyde. So what actually determines that an organic compound is of particular type? That is the functional group which is present in this. So different functional groups are there. You have to learn the functional group, their formula. Like the important functional groups we have like alcoholic group OH, aldehyde group CHO, ketonic group C double bond O, nitriles that is CN, acid group, you are familiar with the acid group, ethers ROR. So these are the important functional groups which determines whether the organic compound, like if the organic compound I am taking like CH3COOH, you are familiar with this acetic acid. So acetic acid is an organic compound in which the functional group which is present here, that is the COH group, that is actually the acidic group. So this group is actually determining that it is an acid. So for any example, the presence of the group in the organic compound which determines what actually it is, that is actually called as the functional group. For example, if I take the case of one example, that is C2H5OH, that is a alcohol. Why it is called as an alcohol? Because here there is a functional group that is OH. OH is the functional group here. So this will determine that this compound is an alcoholic compound. So what is a functional group? Functional group determines the characteristic property of the organic compound. And you need to learn all these functional groups. But if the organic compound which have more than one functional group, then you have to give priority in this order. So the order of decreasing priority of some functional group is given here. So when you compare here, acidic group, that is have the most priority group. Then next we have SO3H group, COOR. Next we have acid chloride group. So when you compare ketonic group, these have less priority in compared to acid group. So if we have any two functional group, we have to give only priority to one of the functional group, that on the basis of this priority sequence. So the details of this one will be discussing when we do the practical examples. So these are the very most important points and the terms which we have learned related to IUPAC nomenclature. So all of you learn all these terms and the different symbols, names for the different groups, so that in the next video you will be getting clear how to name the organic compound. So this is all about this video. Have a nice day.